Hello everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about probability density function. What is probability density function? Probability density function is also known as continuous probability distribution. If x is a continuous random variable, then the probability distribution f of x equal to p of x equal to xi is said to be probability density function. If it has the following properties. First one, f of x greater than or equal to 0, and second one is integration over minus infinity to infinity f of x dx equal to 1. So here f of x equal to r p of x equal to xi is said to be probability density function if it has mainly two properties are there. So first one is f of x is greater than or equal to 0, and second one is integration over minus infinity to infinity f of x dx equal to 1. So problems on probability density function. First one. First question. Is a function defined by f of x equal to, so here we have function that is 0 where x less than 2, 3x plus 3 plus 2x by 18, that is where the limits are 2 less than x less than 4 and 0 where x greater than 4. So this is our function. So then probability density function or not. So here we have to check whether the function is probability density function or not. So given that, what is our function? So here 0 where x less than 2, 3 plus 2x by 18 where 2 less than x less than 4, 0 where x greater than 4. So this is our function. So here we have to check whether the function is probability density function or not. So if it is probability density function, so we have actually two properties are there. So first one is f of x greater than or equal to 0, and second property is integration over minus infinity infinity f of x dx equal to 1. So based on these two properties, we have to check whether the function is probability density function or not. So first we will be focused on f of x greater than or equal to 0. So here by the function we can denote that the function is f of x greater than or equal to 0. So if you substitute x equal to 0, then it will be positive. If you substitute negative value also, it will be positive. So that's why the function is positive value. So that means the function is satisfies f of x greater than or equal to 0. So that means it satisfies the first property of the probability density function. Okay, so now we have to go for our second property. So what is our second property? Our second property is integration over minus infinity infinity f of x dx equal to 1. So check whether the function satisfies integration over minus infinity infinity f of x dx equal to 1. So now we have to write. So what is our function? The function is this one. So based on that function, we have to write the property. So we have to check our property whether it is equal to 1 or not. So that's why integration over, we know that the function integration over minus infinity to infinity f of x dx equal to 1 can be written as integration over minus infinity to infinity, integration over minus infinity to 2 f of x dx plus 2 to 4 f of x dx plus 4 to infinity. So because here we have the function, so the function will be, so our function is, so here f of x equal to 0 where x less than 2. F of x equal to 0 where x less than 2 means that will be minus infinity to 2. So here we have function that is 3 plus 2x by 18. So where the limits are 2 to 4. So here our limits are 2 to 4. So f of x equal to 0 where 4 to infinity. So we have to split the limits to integration over minus infinity to infinity can be written as minus infinity to 2 plus 2 to 4 plus 4 to infinity. So we have to split the limits based on our question. So that's why minus infinity to infinity can be written as minus infinity to 2 f of x dx and 2 to 4 f of x dx and 4 to infinity f of x dx. So, but we know that integration over minus infinity to 2, in place of minus infinity to 2, we have the function is 0. And if we have 2 to 4 limits, based on 2 to 4 limits, we have the function that is 3 plus 2x by 18. If the limits are 4 to infinity, if the limits are 4 to infinity, the function will be 0. So that's why this is 0 and this is 0. So here we have the function. Okay. So that's why integration over minus infinity to infinity, the function will be 0. And integration over 4 to infinity, here also our function is 0. But in the limits of 2 to 4, so in the limits of 2 to 4, we have the function. So the function is 3 plus 2x by 18. So here we have to substitute our function. So in place of f of x, we have to substitute our function. So that is 2 to 4, 3 plus 2x by 18. So here we have to substitute our function. So in place of minus infinity to 2, here the function is 0 and 4 to infinity also the function is 0. Okay. So next. So now we have to take 1 by 18 outside. 1 by 18 outside. So then the function is, if 1 by 18 is outside, the function will be 2 to 4, 3 plus 2x dx. So 1 by 18 integration over 2 to 4, 3 into dx. So that means we have to keep the constant outside, then that will be integration dx. So like that, if 2 is constant, no, we can keep in the outside. So then that will be 2 to 4 x into, here we have function that is x into dx. Okay. So if we simplify this one, then that will be, so integration of dx is x. So like that, 2 into integration of integration of x dx is x square by 2. So now we have to simplify this one. So that will be 3 into x plus 2 get cancelled, then that will be x square. Okay. So like that, 2 get cancelled, the function will be 1 by 18, 3x plus x square. The limits are 2 to 4. So here 2 get cancelled. So first we have to substitute upper limit. So now we have to substitute upper limit. So 1 by 18. So 3x upper limit is 4 minus lower limit is 2 plus upper limit is 4, that is 4 square, minus lower limit is 2. So that means 2 square. So now if you simplify this one, we will get the answer is 1. Okay. So the second property is also satisfied. So therefore integration over minus infinity to infinity f of x dx equal to 1. So here it is satisfying two properties. So first property is f of x greater than or equal to 0. And the second property is integration over minus infinity to infinity f of x dx equal to 1. So if it satisfies the two properties of probability density function, then we can say that the function is probability density function. So like that, we have one more problem. So second problem is the probability density function is f of x equal to k into 3x square minus 2. So where the limits are minus 1 less than x less than 2 and 0 otherwise. Okay. So that means the limits will be minus infinity to 1 minus 1 or 2 to infinity. So here the function will be exist only in the case of minus 1 to 2. Only in the case of minus 1 to 2. So here we have to find only k. So how to find k value? So here we have two properties. So first one is if it is probability density function, then we have two properties. First one is f of x greater than or equal to 0, and second property is minus infinity to infinity f of x dx equal to 1. Okay. So by using in the question they have given that is probability density function. So that means it satisfies the two properties of probability density function. So that means it satisfies f of x greater than or equal to 0, and second property is minus infinity to infinity f of x dx equal to 1. So by using these two properties we can find the k value. So mainly the based on second property, so that is minus infinity to infinity f of x dx equal to 1. So based on that property we can find the k value. Okay, so what is our function? So here our function is k into 3x square minus 2, where the limits are minus 1 less than x less than infinity. So minus 1 to 2. Minus 1 less than x less than 2. So that is the limits are minus 1 to 2. And remaining the value is 0. The function is 0. So that means, so minus infinity to 1, minus 1, the function is 0. And the case of 2 to infinity, the function will be 0. So that is the our otherwise case. Okay. So here we are using the function. The function is probability density function now. So that's why we are using the second property of probability density function to find the k value. So what is our second property? Minus infinity to infinity f of x dx equal to 1. So here minus infinity to infinity, what is our second property? Minus infinity to infinity f of x dx equal to 1, right? So we have to split the limits based on this one, based on these limits. So first one is minus infinity to minus 1, minus 1 to 2, 2 to infinity. So based on these limits we have to split the limits minus infinity to infinity. So minus infinity in minus 1 f of x dx plus minus 1 to 2 f of x dx plus 2 to infinity f of x dx. So already we know that where the case of minus 1 to minus infinity to minus 1, the function will be 0. So and 2 to infinity, the function will be 0. And here the function will be exist. So what is our function? So here our function is, so here our function f of x equal to k into 3x square, k into 3x square minus 2. Okay, so now substitute the function here. So here the case where the case of minus infinity to minus 1, the limits will the function will be 0, and 2 to infinity where the function will be 0. These two are otherwise cases. Okay, so now here we have function, the limits based on the question, the limits minus 1 to 2, the function will be there. So that's why here the function is k into 3x square minus 2. Okay, so these two cases are 0. So that's why k into, you can keep the k outside. So that's why k into minus 1 to 2, 3x square minus 2 dx equal to 1. So k into, so we have to simplify this one. So that's why the integration of, so therefore the integration of 3 into x square integration is x cube by 3 minus 2 into integration of dx. So we know that integration of dx is x, and integration of x square dx is x cube by 3. So that's why 2 into that will be x. So that is equal to 1. Through 3 get cancelled. So k equal to x cube, so minus 2x. So here the limits are minus 1 to 3. Sorry, minus 1 to 2, right? So minus 1 to 2 equal to 1. So k into, first we have to substitute upper limit, that is 2 cube, minus lower limit minus 1 cube. Okay. So minus lower limit is 2 into x. So you can keep the 2 outside and x. First upper limit 2 minus lower limit is minus 1. So here upper limit is 2 and lower limit is minus 1. So always we can substitute upper limit minus lower limit. So upper limit for this, upper limit is 2 cube minus lower limit is minus 1 cube. Okay. So here upper limit is 2 and lower limit is minus 1. Upper limit minus lower limit. Upper limit minus lower limit. So if you simplify this one, you will get k value. Okay. Next problem is find the constant k so that the function f of x is defined as f of x equal to 1 by k where the limits are a to b, a less than x less than b and 0 otherwise. So here we have to find the k value. So how to find the k value? So if the function is probability density function, then how can we find the k value? So we have two properties. So first one is f of x greater than or equal to 0 and second one is integration over minus infinity to infinity f of x dx equal to 1. So based on this property, we can find the k value. So that's why we are using this property. Okay. So what is our question? So f of x equal to f of x equal to 1 by k where a less than x less than b. So a to b. So limits are a to b. The function will be exist. The function is 1 by k and 0 is otherwise case. So that means, so here we have minus infinity to infinity. So based on the probability density function, so here we are writing minus infinity to infinity f of x dx equal to 1. So by using this, the limits can be splitted to minus infinity to a plus a to b plus b to infinity. So these two are otherwise cases, right? So that's why this in these two cases the function will be 0. So here the function will be exist. So that can be written as minus infinity to a to b, b to infinity. So minus infinity to a f of x dx, a to b f of x dx, b to infinity f of x dx equal to 1. So these two are otherwise cases. That's why the function is 0. Here the function is f of x equal to 0 and the function will be exist here. So here the function is f of x equal to 1 by k. So substitute 1 by k here. So and you can keep the constant outside. So that's why 1 by k into integration of here 1 dx. So we know that integration of 1 dx is x, right? So that's why, so 1 by k into integration of dx is x. And what about the limits? A to b. So that is equal to 1. So for this, okay. So 1 by k, so upper limit minus lower limit. So here upper limit is b and lower limit is a. So that's why b minus a. So that is equal to 1. So 1 by k equal to b minus a and k equal to b minus a. So this is our k value. Okay. So here we have one note, that is if f of x is a probability density function or density function, then probability of a less than x less than b, probability of p of a less than x less than b equal to integration over a to b f of x dx. So that means if we have the limits, then we can directly write integration over a to b f of x dx. That means, so here we have function, right? So the limits will be exist only in this case. So that means directly we can write integration over minus infinity f of x dx equal to 1 can be written as, directly we can write integration over a to b f of x dx equal to 1. So no need to write like this, integration over minus infinity to a plus a to b plus b to infinity. So directly we can write here with the function will be exist now. That's why integration over a to b f of x dx equal to 1. So next problem, a random variable x has the probability density function. So that is f of x equal to 2 into e power minus 2x where x greater than 0, 0 where x less than 0. Okay. So that means x greater than 0 means that is 0 to infinity, right? A random variable x has the probability density function f of x equal to 2 into e power minus 2x, 0 where x greater than 0 and 0 where x less than 0. Find P of 1 less than x less than b. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.